Hi, everybody. Welcome back to Chemical Man Podcast. I'm your host, Chris. So today we're going to talk about distillation. I made a very simple diagram of a distillation column. Nothing fancy. Excuse my drawing, but we're going to talk about different things. Okay. So the first thing we're going to talk about is you got your column. Okay. All should have trays in there on your column. You're going to have a circulation pump down here on the bottom. So it comes off the bottom of the column, goes to circulation, goes up through a reboiler. On the reboiler, it's going to be a tube sheet like this, right? So you can look all this up. It's pretty simple. So you can have little tubes in there, all in there, right? And as it circulates through here, all the liquid goes through the tubes and back in the column. And so on the outside of the tubes, to heat it up, you're going to introduce steam to it on the top. Steam goes to there, fills up, condensate goes out to a condensate tank or whatever kind of place you have it go to, right? So as this circulates like this builds up heat in here. And as it builds up heat in there, it's going to, and with the vacuum on it, it's going to send your light ends up and go overhead. And that's going to be your good stuff that you're making, right? On there. So these trays help hold stuff on there as it goes through. Anything heavy is going to fall back down on there as it goes up. The vacuum pulls it over to your main condenser. Your main condenser is also a tube sheet like this. It's going to have some kind of cooling tower water go through it, something like that, depending on what you're making. You also got a vent condenser. Your vent condenser is on the side. It's going to have refrigerated water. It's also going to help on that. It's also a tube sheet on that vent condenser too. So you have refrigerated water in and out. You have cooling tower water in and out, or whatever you use for your cooling system on your main condenser, okay? You're going to have a vacuum pod up here, right? So this right here is called an ejector, right? So it's round on the end, and then it goes small, right? So it's almost like a bullhorn kind of thing as you go through there. Anyway, as steam goes through it, it's going to pull up. So as steam goes through here, it's going to pull a vacuum through there, and from there it goes. And what we have an inner condenser and after condenser, and these inner condenser and after condensers take steam, and what goes through there, because steam, like a liquid, but it's real hot, goes through there and goes to these inner and after condensers, and you have cooling tower water on those. And those condense back down to water. So they'll go down to wherever you may have it, to like a jet condensate tank or a knockout pot or something down there. And they'll use it for something else. But anyway, steam goes through, pulls back into the vacuum pot, and goes through there. This vacuum pot will connect to around your vapor arm where it goes into your main condenser. And that will pull vacuum for the whole system, right? On there. And if you need to do vacuum checks, usually a lot of times they'll have a little valve right here. You can pull vacuum on the column, close it, do your vacuum check on there, make sure there's no leaks anywhere on that. If it holds vacuum, then you're good to go on that. So kind of your overview here goes down to a distillate receiver right here. These two drain down to a distillate receiver. This is your good product. Good product goes back to a reflux, back to the column, to the very top tray. It keeps that top tray cool, keeps it wet because you have a lot of heat in here. And then it sends everything back down. So as a reflux back to the column, material goes down while the good stuff goes up, and just puts your heavies down at the bottom and your good stuff back up, right? And then this is your good stuff, so it also goes to your rundown tanks over here. And some of them go through a cooler, so it cools down the material too on there. A lot of times you'll have your cooler, either refrigerated water, cooling tower water, whatever it is. So this is a certain degree, goes through there before it hits your tanks, rundown tanks, and cools down on that. Okay, so you have different types of circulations too, okay? You have your standard. A lot of them are belt driven. It's a big motor and it's got a belt on it and it circulates on that. Some of them are regular motors / pumps. They circulate too. Then you get into this thing that a lot of people don't really discuss about called a thermosiphon. And thermosiphon doesn't use any kind of circulator or pump or anything. It just kind of connects to the reboiler. As steam goes in, it goes through, and then I can't really explain what it does inside, but it moves through. And as it does, almost like a vortex or something, as it moves through there, it causes it to circulate the way the steam goes in on there, and it causes it to circulate in the column too and goes through. Now, you might look at this column and be like, well, when it says 100%, that means the column's full. No. So as you circulate back in here, usually your level's right below to where it circulates back in. When it gets 100% level of the column, that means it's up above where it goes back into the column. So it might be like right here, maybe 100% on there. This might be 50. And then when you get above where it circulates back in the column, it might be 100% on there too. You're going to have like inhibitors that go to columns too to help if you got any kind of polymer or anything in there. It's going to help with that. Also, so you're going to help with pushing down the heavy stuff on there. You're going to have a bottoms pump on there, out there, depending on what it is, what you're making. It could be like real heavy bottoms. You send that out, so as you circulate, you're always got new feed coming in, circulating and heating up, and go from there on that. Real simple overview. It looks like a lot, but it's not. So you're going to get your level into the column here. It's going to circulate through your circulator. You're going to have your steam come in through your tube sheet. It's going to go on the outside. The steam never touches the material. Remember, it's a tube in there, and then it goes around the whole thing. So as the material goes through there, it'll circulate through there while the steam goes around it on the outside, right? And then as you pull your vacuum, it's going to boil, it's going to circulate, it's going to boil. And then when you pull your vacuum helps pull the good material over. It's going to go over through a vapor arm. It's going to go down to like a main condenser where it's got usually cooling tower water on it. You also got a vent condenser, so if anything, so it also goes over there. It's got refrigerator water on it. Usually those two will go down to a distal receiver. Some places have separators. It's a big long thing. You have an aqueous and organic side with a weir maw. We'll talk about that later. That's something different. Okay, and then you're going to have a reflux back to the column. It's going to be your good material on there. Also helps with the top tray, everything on there. You're going to have inhibitors in different areas, wherever you have on that. And then if you're making the product, it's going to go down to your rundown tank and stuff like that, right? Your tube sheet's pretty simple. It's got a bunch of holes in it. It's actually a tube in there. And then on the outside of the tube is where it heats it up through there. What else can I say? You're going to have trays. I think I said that. You're going to have trays in here all through the column. You're going to have trays. And that helps with a lot of things. It helps put inhibitor on those trays. It helps keeps heavies down, helps with polymer on the tray. So nothing as the material comes up, it doesn't get into one spot and it just sits there and cooks. It's going to help with keeping that tray wet and everything on there, on that. But just an overview of a distillation column. There's several things we can talk about on here, and I just wanted to kind of start this with this. And I hope some people have some questions on that. Some people pull vacuum different ways. And I can talk about I'll talk about different ways on some more videos about things you can look for, why you can't pull vacuum. If you're having vacuum problems, things you can look for. If your circulating's good, if you're showing a level in the column, but your level's heating up, I'll talk about that, what to do on that. You think you got inhibitor flows, but you don't, what to do on that on there. All of a sudden you start taking your sample and your sample looks weird, like, wait a minute, I'm starting to get a lot more water in my column than I should on my distal receiver. Why am I getting more water? Could be things. Could be one of your tubes is cracked and you got steam and water leaking in through your tube, so that's causing more water in there. That's another thing to look at. You have to look at that on that. Could be just whatever you're putting in there, water from a different unit on there. So a lot of things to look on that too. There's an overview on distillation column. I just wanted to get this out, show everybody, but I will have a lot of different things. But yes, look up thermo siphon on there, and that's pretty interesting about not using a circulator on there, about how that works. That's pretty interesting. Look up that. If you have a problem, look up tube sheet. See how that looks if you get on there. There's a lot of different things out there, but this is it. So once you get material in here to a certain level, you would kick on your circulator. You would do it. Now, a lot of these reboilers also have cooling tower water go to them, because if you have to shut down real quick and something happens, you got to turn your steam off and you got to line up cooling tower water. So steam goes in the top and then out the bottom for the to heat it up. Cooling tower water goes in the bottom and out the top. So when you put cooling tower water, it fills up the whole thing. It's just circulate. It keeps it colder. If you were to put cooling tower water like that and it circulates, it wouldn't cool down as fast. So the cooling tower water goes in the bottom. These have always either cooling tower or refrigerator water on there, depending on where you at. Work on that. So anyway, anybody got any questions? Leave some comments down below. Anybody see anything different they want added on there? But I'll have some more videos out. I'll talk about just going over problem solving of different things on there. And until the next time, y'all have a good one.